Hi everyone. Today we're going to study antiderivative of a function. Let us define antiderivative of a function. A function capital F is an antiderivative of the function small f if capital F prime of x is equal to small f of x for all x in the domain of f. For our example, recall that g of x is equal to x squared and the derivative g prime of x equals 2x. Now, when we have f of x is equal to 2x, the antiderivative is capital F of x is equal to x squared. Note, finding antiderivative is the reverse process of finding derivative. Now, let us go to the general form of antiderivative. In our example a while ago, the function small f of x is equal to 2x. And we say that the antiderivative is capital F of x equals x squared. Because if we take the derivative of x squared, the answer is 2x. Now, there are other antiderivatives for the function 2x. I will write one example. F of x is equal to x squared plus 5. The derivative of this function is 2x. Another example is capital F of x equals x squared minus 7. The derivative of this function is the function 2x. So we see here that these three functions are antiderivatives of the function 2x. So we have this capital F of x plus an arbitrary constant c. This is now what we call the general form of antiderivative. Let us see more sample problems. Find all antiderivatives of the following functions. Our first function here is f of x equals 3x squared. For our solution, we know that the derivative of x cubed is equal to 3x squared. Then, capital F of x is equal to x cubed is an antiderivative of 3x squared. Therefore, every antiderivative of 3x squared is of the form x cubed plus c. So our final answer here is the capital F of x is equal to x cubed plus c. Next is the function f of x equals 1 over x. We know that the derivative of ln x equals 1 over x. Then, the capital F of x is equal to ln x is an antiderivative of 1 over x. Therefore, every antiderivative of 1 over x is of the form ln x plus c. So our final answer for the antiderivative is capital F of x is equal to ln x plus c. Function c is f of x equals cosine x. We know that the derivative of sine x equals cosine x. It means the capital F of x equals sine x is an antiderivative of cosine x. Therefore, every antiderivative of cosine x is of the form sine x plus c. So our final answer is capital F of x equals sine x plus c. function for f of x equals e raised to x. We know that the derivative of e raised to x is equal to e raised to x. Then, the capital F of x is equal to e raised to x is an antiderivative of e raised to x. Therefore, every antiderivative of e raised to x is of the form e raised to x plus c. So our final answer is capital F of x equals e raised to x plus c. These are our final answers. I hope you learned something from this video. See you again next time.